We've popped into BCW Treatments, part of the BCW group, and we're going to have a chat with Andy, who is a master of surface treatments. Amazing facility behind us. First, tell us about it, Andy.
Well, it's a fully automatic sulphuric acid anodising line. It's one of a couple in the country that can serve the automobile industry for lightweight bonded structures.
Okay, so first we'll take a step back. Anodising, for those who don't know what it is, just a very, very brief overview of that.
Anodising is nearly 100 years old technology. Right. It's sulphuric acid anodising. Typically it's a car battery acid. Process is cleaning the product. We then etch the product, which takes the natural oxide. Aluminium naturally oxidises like ferrous material, so we remove the oxide coating. It then goes into a series of rinse tanks, and it's put in an acid desmut, which desmuts the alloying elements out of the aluminium substrate itself. We are then left with a clean aluminium substrate, which goes into electrolytic cell, which is the anodising process.
Okay, that anodising is then coating it for what sort of reasons would you coat it?
The coating is predominantly to provide corrosion resistance in what a typical anodiser would, architectural. But what we have to do, we have to provide corrosion protection, but also provide bond durability, because the end sector of our product is a glued chassis.
Now, two things, I want to stop you there and say, when you say the anodising process for architectural, like the bull ring in Birmingham, for example, it's just, it looks good.
It looks good. Yeah, okay. The colours match. It has to be a minimum thickness, maybe 10 to 20 microns, to provide full corrosion protection. Yeah.
And bond durability, that's not French, that's bonding as such.
That's bonding. It's gluing a chassis together, so it's not welded. The majority of the strength of the chassis comes from the bonding. There is some mechanical fixings, but it is the anodising film that provides the integrity for the bond.
So these are, I mean, you're doing automotive, aerospace, what other industries?
We're predominantly automotive, do aerospace. We have some panels that have gone on satellites, which has been machined through our precision company. And we're starting into electric vehicles. So as well as niche sports car manufacturing, where you do need a rigid lightweight structure, we're also hitting the electric vehicle companies, which require a lightweight chassis. Okay,
now I'm thinking as well then, with this process, the car panels, whatever vehicle they might be on, they're critical components, so this has got to be repeatable and accurate.
Absolutely, the safety critical components. At the minute I'm anodising 10 to 15,000 components a week, from one of the largest single pieces of aluminium on a car, which is what we call a DOR, which is basically a side...
Not a door.
Or a door, DOR, not the double O. From small safety critical pieces that tie the seat to the chassis. So there's a lot of safety critical parts on there.
Fantastic facility here, fully automated, but it also ties in nicely with sort of the data management system over here. What does that actually do?
We have a large number of parts of different geometries and different alloys. At the minute we're currently doing about 300 chassis parts, so could be from 3.5 square metre part down to 0.1 square metre or even less. We have a number of different alloys which we cannot mix. So we have casting material, we have sheet material, we have extrusion material, and some niche products of that. The data management system is the part library, or the brains of the process. It selects the parts, what bar it can be jigged on, what it cannot be mixed with. It knows exactly what the wettable surface area of the product is, so it then can deliver the correct current density and voltage in the electrolytic process to maintain our strict specification of between 2 and 10 microns.
And as I said, Andy, master of surface treatment, clearly you've done this quite a bit, haven't you? Now, this, as I said, fantastic facility. Passivation next?
Yeah, we've just had our internal business plan signed off for a new passivation plant. It's another style of chemical conversion coating, and again it's going to supply UK Automotive and UK Aerospace business.
So based on a similar process, this in terms of full automation?
Similar process, full automation, just slightly different chemistry, and it's not an electrolytic process as in anodising, but it will be a plant that looks blue and yellow with 2 transporters whizzing up and down.
Oh, you make it sound simple, but what's the next step?
The next step, we are currently sponsoring a PhD student at Manchester University in the Advanced Materials Department. As I mentioned earlier, the traceability systems we have in the anodising is second to none. But anodising itself is 100-year-old technology. So we're looking at a novel process that we worked on a bench top, where it'll do away with pre-treatment, various rinses, hot seal process. It will virtually be just electrolytic tanks blasting the surface.
Brilliant.
So environmentally friendly surface.
To Andy, this is an absolutely amazing facility. We look forward to seeing the passivation, but we also look forward to seeing the next step in the future with your PhD students. Master of Surface Treatments, thank you very much.
Thank you.